Dear students, let's continue to set the frequency table. The frequency table definition is a grouping of data into mutually exclusive classes showing the number of observations in each class. Let's remember the definition of the mutually exclusive. As we said before, the mutually exclusive means that the value not appear in the two classes in the same time. If we are interested in count the group of data or who are participated into male and female, the person may be male or female, never be the two gender in the same time. If we interested in adding data that is acceptable or not acceptable, the data may be accepted or not the same values in the same time. So this is the meaning of the mutually exclusive classes. These steps are assigned to set the frequency table. First, we will decide the number of classes and put this rule to the value are obtained for the classes. 2 to the power k should be greater than n, where n are the number of sample size and k are the number of classes that we are interested to put it in the frequency table. So we will try up to get this value greater than the sample size that is given in your example or in your situation. The second step, determine the classes interval or width. This formula, that's the I, which is the class interval or class width, should be greater than or equal the highest observed value minus the lowest observed value divided by k. K, which we already get in the first step, that represents the number of classes, and the highest value from the situation or the data given in your example minus the lowest observed value in the situation. So we will calculate and divide it by the all over number of classes. This value should be less than a class interval or class width. Step number 3, set the individual classes. Set the individual classes based on the lowest value. We start by the lowest value in our data. And step 4, we will tally the ungroup data to raw data into classes. In this step, we already convert the ungrouped data to group data and ensure that all the classes are mutually exclusive and exhaustive. Number 5 and final step, count the number of tallies in each class. Number of tallies should be equal to the total number of data given. Let's take an example. The following data represent the degrees for 20 students in pure mathematics exam. Here, this example may be presented in a real life. We have already 20 students as a sample from students in mathematics exam, and we wanted to know data between and calculate some calculations and to get information from these data. But these data and values are ungrouped data and have no meaning if we use it as it. We want to organize it into a frequency distribution table to benefit from it. So the first step we will use 2 to the power k greater than n to determine the number of classes. 2 to the power k greater than n to determine the number of classes, where k is the number of classes that we want to determine, and n is the 20 students, that the number of sample size. So we have the 2 to the power k should be greater than n. Let's use 2 to the power 5 greater than n. Yes, because 2 to the power 5 equals to 32 and 32 greater than n. So we will use k, the number of classes, equal to 5. This is the first step. Then we will use the second step to determine the width for each class or the class interval by using the previous rule. The highest value, which is 98 minus the lowest value, which is 51, divided by k, which is equal to 5, the number of classes. So the class width or class interval that will be equal to 9.4. Okay, so the second step, I should be greater than or equal highest level, which is 98 minus, okay, let's take this, 98 minus 51 over 5. So I, which is the class interval or class width, should be greater than or equal 9.4, which is the class interval obtained. To simplify the calculations, we'll use the class interval equal to 10. Okay, so to answer the first question, how many classes would you recommend? We will use the rule 2 to the power k greater than n, and we recommend in this case 5 classes. And for the second question, what class interval would you suggest? The class interval I suggest 10 classes. Notice that in the question we say recommended, suggested, because the value may vary. From answer to other. But we put a rule that we will use in the solving our problems. Let's here round the number to the nearest tens, to p, 10, 15, 20, to simplify our calculations in the intervals. So the class interval may be 5, 9.4 or 9.5, 9.9. To simplify, let it 10 to get the class width easy to calculate in each class. Number C, what lower limit would you suggest for the first class? Again, the question use the words suggest or recommends. This is because the answer may vary. Note that you may suggest the lower limit equal to 51, and it's true. Another one use 50, also true. Another one use 45, also true. But we will use 50 to simplify the calculations and get easily classes intervals to get and midpoints. So we will use the nearest tens. If we have 51, 52, we'll use 50. If we have 99, maybe use 199, we will use the lowest value 95 to get the values for the tens, 0 or 5 or even number to simplify the calculations as stated before. So the first three steps may depend on your recommendation and suggestions. Be careful to set these steps in an easy way to easily the calculations for the suggested classes and the intervals. Number D, organize the degree into frequency table. Now we will tally this information in the table and count all values by using a tallies and never never repeat any value 2 times, and you should take into consideration when putting the values into a frequency distribution table, the values should be mutually exclusive and exhaustive. Mutually exclusive means that the values don't appear in 2 classes in the same time. I mean, when we put, for example, 70, we don't put this value in the class 2 and the class 3 in the same time. Each value appears only one time. Okay, this is a mutually exclusive classes. So let's organize the table like this. After tally, we said that it began with the classes with the lowest value, which is 50, and the class interval from 50 up to 60. Up to 60, the width or each class is equal to 10, and as we calculated in the second step. So we have 5 classes as we suggested in the first step. So the first step from 50 up to 60. This means 50 not included in this class, but it's included in the second class, which is from 60 to up to 70. 70 not included in the second class, but 70 is included in the third class, and so on. After tally the data, we have these frequencies. The frequencies in the first class, we have 4 values in the class from 50 up to 60, in second class 5, third class 6, and fourth class 2, and finally the fifth class have 3 values. You should note that the value summation of the frequencies equals the total number of observations, equal to n. No more than or less than the given data. It should be the summation of all frequencies equal to the sample size given. Here we want to get what is noted by class midpoint. Class midpoint is a value in the mid of each class. I mean, when the class begins with 50 and ends with 60, the midpoint is 55. For this example, it's easy to know that it's 55 in between 50 and 60. But in reality, we should use a rule because sometimes we have a decimal number for the classes. How calculate it then? So we will use a rule that to get the class midpoint, we will use this rule: the lower limit plus higher limit over 2. For the first class, let's apply the rule. So it's equal to 50 plus 60 over 2 equal to 55. This is the midpoint for the first class. To get the midpoint for the second class, it's 60 plus 70 over 2 is 65, and so on up to the fifth class. You may, in this value, get it by using your experience numbers, that is 55, 56, 65, 75, 85, and 95. But you should know this rule because you may use it in other examples. Then we will get another column that we will use it in our situations and examples and exercises, which is the relative frequency. We get the relative frequency by dividing each frequency by the total values. And the relative frequency make connection between the value in each class and the total sample size, and give me us indicator about this relation. So if we look at the relative frequency, we find that 0.2 of the frequencies in the first class, okay, and 0.25 in the second class. And we have a quick look to the values. Oh, it's a quarter of the data is in the second class. Okay, so it gives us a quick look to the values in a relation with the total sample mean. So the relative frequency is the important indicator for us. So how to get the relative frequency again? Now let's use the rule of frequency. Relative frequency divided each frequency by the total data. Here we get the 0.2 by dividing 4 over 20, and get 0.25 by dividing 5 over 20, and get 0.3 by dividing 6 over 20, and so on. Note that the total value of the relative frequency should equal to 1. If it's not equal to 1, there's something wrong in your calculations. Be careful to get this value summation equal to 1. So the relative frequency in each class enable us to show the relation in between the values in frequencies in each class and the total sample size. Now, in this step, we will get the values of cumulative frequency in the final. In this, we will take the values for it, the cumulative frequency in this column. How to get the cumulative frequency values? This is by dividing, this is by adding each class value to the class P4 to know the values for cumulation in all the classes. Let's start. When we are in the first class, the value obtained from the class P4 is 0. We haven't already class P4 50 up to 60. So the value will be the frequency 4 plus 0 equal to 4. Now let's move to the second class. Here we have class frequency in the second class 5, and we already have 4 in the previous class. So we will add 5 plus 4. So the cumulative frequency in the second class will be 9. But let's move to the third class, which is we have 3 numbers or 3 frequencies cumulative. So we will add 4 plus 5 plus 6. 4 plus 5 plus 6, I mean 9 plus 6. So the cumulative frequency in the third step will be 15. For calculating the cumulative frequency in the fourth step, we have the values frequency in the fourth class 2, and we already have 3 values here, 4 plus 5 plus 9. We add all up to 2 to get 15 plus 2 equal to 17. Finally, we get the cumulative frequency for the last class or fifth class. We get 3 plus the all the frequencies before to get 3 plus 17 will equal to 20. Note that the value 20, the cumulative frequency in the last class, should equal to the total sample size or the total summation for the frequencies. You should get the same value. If not, there is wrong something in your calculations, and you should repeat your calculations again. This is all for frequency distribution table. Let's take some definitions that we use in the frequency distribution table. The first definition is class interval. The class interval is obtained by subtracting the lower limit of class from the lower limit for the next class, or by using the rule that we use already, adding the lower limit plus higher limit. Okay, this is the for class interval. Another definition with the class frequency. Class frequency, the number of observations in each class. And finally, the class midpoint is the point that divided a class into two equal parts. That's in the middle, so the two equal parts. This is the average of upper and lower limit classes and calculated by the rules that we are used, that is lower limit plus upper limit minus over 2. Let's now know the definition for relative frequency distribution. To convert a frequency distribution to relative frequency distribution, each class frequencies is defined by the total number of observations as we did in the relative frequency column. A relative frequency captures the relationship between the classes total and the total number of observations. Now let's move to how to represent these data in a graphic presentation. We have three commonly used graph formats for the group data. The group data that we have in the frequency distribution table, we use three commonly graphs. Of course, there are more than three graphs, but we studied the most common, which are histogram, frequency polygons, cumulative frequency distributions. So let's start with the histogram. Histogram, as appear in this chart, have two axes. In this axis, we put the class intervals or class widths. Okay, and we put here the frequencies. And here we put the class intervals. So the sorry. So we will put frequencies suitable values in our table. If we have values 10, 90, 50, 40, we will put the frequencies 10, 20, 30, 40 up to 100. If we have all the most greater value is 40, it enables us to get the even number to put in the frequency line. So it's up to you when you decide how to get the frequencies in the frequency axis, but be careful to put it related to the frequency numbers. Here we set the in x-axis or in the horizontal axis we put the classes from 0 up to 10, 10 up to 15, 15 up to 20, 20 up to 25, up and so on. And we will start to put the data from the table on the graph. Note that in histogram it differs from the bar chart that we studied in the previous lectures, because the histogram have no gaps in between the bars. They are adjacent. Look, they are adjacent to each other. No gap in between intervals. This is why, because the classes was adjacent to each other, 50 up to 60, and then no gap. Quickly we began with 60 up to 70, and then 70 up to 80. There is no gap in between classes, so there is no gap here again in between the bars, and there are adjacent bars. Note that when you draw the histogram, and this is the difference between histogram and the bar chart. So let's define the histogram. Histogram is a graph in which the classes midpoint or limits are marked on the horizontal axis and the classes frequencies on the vertical axis. The class frequencies represented by the highest of the bars and the bars drawn adjacent to each other. Okay. Another histogram. Okay, here classes begin with 200 up to 600, 600 up to 1000, 1000 and 1040. Here the class interval equal to 400, the higher lower limit minus lower limit to get the class interval. And here we draw adjacent bar. This is a histogram. The second graph that we will study is a frequency polygon. The frequency polygon consists of line segments connecting the points formed by class midpoint and class frequency. Note that in the frequency polygon we don't use the class intervals, but we use the class midpoints. So this is the difference between the frequency polygon and histogram. And we draw the frequency on the vertical axis as noted before, and we draw it in the histogram, and on the horizontal axis we take the values for the class midpoint. When we draw the midpoint, we start with the midpoint. In the first class, we find it 400. For the second class, 800. And the third class, 1200, and so on. Here, but the values will start here equal to this value, begin with this value, and ends with this value. And we don't have zero frequencies. So we will add the polygon at zero frequencies, which means that we will subtracting the class interval from the lowest limit midpoint and adding the class interval for the highest midpoint. Here the class interval equal to 400, so we will put the 400, which is the lowest midpoint minus the class interval, which is 400, equal to 0. Then the first point it will be 0 and 0. And we will, to get the highest value, we will add the class midpoint to the highest midpoint. The highest midpoint equals 300, 3200. Adding the class interval, which is 400, equal to 3600. So we will adding the 2.0 and 3600 in the horizontal axis, and then join it with our graph and make line segments starting with 0 and ending with 3600. By using ruler, you can join these points. So, what is the difference between the histogram and the frequency polygon? Both provide a quick picture of the main characteristic of the data. We can use here what the class interval. The highest one is from 1000 class started with 1800 up to 2200, and the frequency in this case is 45. This is a very quick review, and we can also know the lowest values in the classes in between 3000 and 3400, and the frequency in this case is equal to 4. Now, very quick picture for the main characteristic of the data: height, lowest point of concentration, how to improve these two pieces, and so on. Another advantage of histogram, despite the classes in a rectangle, so it appears very easily. The quick picture may be in the both to the histogram and frequency polygon, because we can here, this is the highest point, this is the lowest point, and the curve high, then lowest again. This is the quick picture. But in the histogram, the rectangle class of the bars, we enable us to presenting it clearly, so we can use it very easily more than the frequency polygon. And also, besides that, frequency polygon uses the midpoints, but the histogram uses the class interval. Okay, now what is the advantage the frequency polygon over the histogram? The advantage is the frequency polygon allows us to compare directly two or more frequencies distribution. This I mean that we can draw two or more, maybe three, in the same axes, x-axis and y-axis. But we can't do this with histogram. We can't draw two histograms in the same time directly and compare it in one frequency distribution chart. So this is the advantage and disadvantage for us. If we use the relative frequencies, the histogram will be the same shape, but the difference only that the vertical axis will represented in percent instead of number. I mean that we have this chart and the class interval from 5 up to 10, 15, 20, for example, and we have parts like this. Okay, we may have here not frequency, but we can use this for the relative frequency. Okay, yeah, let's go by numbers: 0.2, 0.4, 0.6, 0.8, and finally 1. As we mentioned before, the relative frequency should sum total equal to 1, which is 100%. So the relative frequency, we can use the part chart with the histogram with the same shape, but the only difference that the vertical axis is a relative frequencies, not frequencies. Okay, this is for today. You have another quiz exercise. You should try to do this, organize this information, this data, into frequency distribution table, and draw number. This is number A, number B. Draw histogram, number C. Draw a frequency Polygon. Polygon. Sorry for this. Polygon. Try to solve it, and we will have more and more exercise to enable you to be perfect in organizing information in a frequency table. Thank you.